we are going to. So we are not going to discuss anything related to pushing or pulling and stuff like that. So these things mainly come in session 3, which is a very good place to also discuss or introduce you about GitHub. Hope so this is the set agenda. So let me jump in straight away, because even though I'm planning it to finish it within 1.5 hours, it's actually taking more than what I'm expecting. So let's straight away jump into the topic. So this slide is basically the recap, like I said. So uh, I'll pause after this slide, so that if you guys have any dumb questions, no matter how small or how basic it is, I want you to get comfortable with this specific slide, and then so that we can easily move on with the next topics, which is about branching in Git. Okay, so the first command that we discussed last time is git init. So git init is mainly to enable a project, be it your folder which has like bunch of files, bunch of your lab programs. And how do you enable it with git? So git init is the command that we use to convert that project so that git can start tracking. Okay, and then git status, which is basically the command that we use every time in order for you to know what files changed, or like what is the state of the project. Just to recollect you, repository or project or those words are basically synonymous. So sometimes I keep using repository or repo, or sometimes I'll be using project. Both are one and the same. I'm just referring to the folder which contains your programs, which is also being tracked by Git. So git status is a command that we use to basically to know the status of the repository, status of the project. So I can essentially see what are all the files modified and stuff like that. Now, once you enable Git, what we saw in the previous session is how do we add files. If they are new, we do add, or if you modified any files, you add them so that they go to staging area, staging step. And then finally what you do is you commit them. Committing means basically you pack them, and basically you put a seal on them. So these are the two commands that we tend to use very often. So every day in and day out, whenever you work with your programs, you basically do git add and then git commit. If it is an existing file, you can also skip adding git add command. You can just do git commit -a. So that basically adds the files and then also commits them. So this part is very crucial, which will be used almost 90% of your workflows whenever you use Git. And then we also one analogy that I gave last time is commits are nothing but very similar to your transactions in your bank statement, right? So in order for you to see what commits you made on that project, we use git log. So git log essentially show you a track record of what transactions or what commits you made. So this is also one of the most frequently used command when you're working with your Git repositories. And then in case of transactions, bank statements, it's either credit or debit. So just by looking at that transaction entry in your bank statement, you can clearly say whether it's a debit or a credit. If it is a debit, you add it to get your previous balance. If it is a credit, you subtract it to get your previous balance. It's very easy for you to look at what is happening to your balance in case of a bank statement. But unlike code, where you make a lot of changes to your source file, so just by looking at the git log output, you won't be able to tell which files got modified, or what new files got added, or what existing files got deleted. And those things you cannot simply say by looking at git log, right? So that's where we use git diff tool essentially. So git diff tool will help you exactly see what has gone into that commit, what changes have gone into that commit. So we use git diff tool. While I was discussing these two commands, I also brought up the point of what is head. Head is basically an alias, a shortcut for you to refer to a commit. Like I said, every commit has a commit ID, the way every transaction has a transaction ID. But it's slightly difficult for you to copy the commit ID and then use it in every command. It's not very smooth, or it's not very easy. It looks very cumbersome when you have to copy the commit IDs. So what Git did is it created this aliasing syntax where head in capitals, HEAD, head, will refer to your topmost commit. So any command which accepts a commit ID, you can actually give it head. So like I said, diff tool is used to inspect the contents of a commit, right? So you could actually give the commit ID, but because it's not so easy to use, what we generally tend to do is we tend to use head. We basically give, let's say I want to look at what changes have gone into the last commit. Last commit, I mean the recent commit. What I do is git diff tool -d head tilde 1 dot head. So like I mentioned, that's a range syntax where you give what commit you want and up to which commit you want to see the changes. Okay, I hope you have a basic idea of it. If not, I'll do some live demos. That's where we can revisit if it's not very clear to you. Yeah, so that's about inspecting the commits. And then finally what we saw is in the event of making a mistake. So how do you undo things? You accidentally added a file which you are not supposed to add. So how do you remove it, right? So if it is already committed, then what we do is we have to unpack the commit. That's where git reset come into picture. So we use git reset, which will unpack and put all the changes there. It won't delete those changes. It will keep those changes. So if you don't even want to have those changes, you can use git checkout. Okay, so these are the things that we have seen, and so this is what you will be using for the most of the time if you ever have to use git, which I'm sure you will be using once you come out of the colleges and get into any sort of a company. So with this, one minor warning is basically some of the git commands that we saw has this dual role. Like I said, git checkout is used for discarding the changes, discarding the modifications done to a file. But the checkout can also be used in other contexts as well. So just keep that in mind. Don't get confused. Like some of these commands get used in different ways, different context. They mean different when used in some other places. Okay, so I'll stop here. I want to know if you have any questions on this. I'm more than happy to give you any examples if you are still not very clear with these concepts. Let me just pause here for a couple of minutes. So also the reason why I didn't want to include GitHub in the first place is once you understand these concepts working locally, it becomes so much easy for you to in fact the moment I introduce GitHub, it almost seems very trivial for you, um, unlike what you could learn in some other tutorials or some other places. So this is the basics that you need in order for you to understand GitHub. It's just a minor extension to what we will be seeing in session 1 and session 2. I hope looks like you guys have no questions. If you have any questions, feel free to stop me even in the next slides. I want to make sure you people actually understand the importance of Git and how to use it in your day-to-day stuff. Okay. Up until now, we basically saw creating commits, inspecting commits, undoing commits. That's exactly what we saw in last session, which ran up for like 2 hours. Now, the problem with just limiting ourselves to creating commits is scenarios like this will arise. Let me give you the scenario. So you created a project and you have been working on that for like 10 days. And since you're working for 10 days, you accumulated a lot of commits, right? You created day one, you created a couple of commits, and day three, you created a couple of commits and things like that. Now, at the end of those 10 days, you're supposed to release that product, right? So what you do is you build that application and then you deploy it. So if it is a web application, you deploy it. If it is a desktop application, you compile it and give it to your customer. And then customer starts using it. Now, what happens is customer after 10th day or 20th day or something like that, he reports a bug. He reports an issue in your code. So it is expected to work in a certain way, and it is not working in, or it's working in a slightly different way. Now, within these 20 days, after you released your product, within these 20 days, you won't sit idle, right? You basically start improving your product. You would be adding new features to it, or you would be changing the existing code in whatever way you want, and then you keep improving it. Now, after 20 days, the customer has reported a bug to you, and you're supposed to fix that. Now, the challenge here is after 20 days, when he reports a bug, you are no more at the code at which you shipped, right? In the first 10 days, you coded it and then you released the product. But your code didn't stay still, after remaining 20 days, you keep on changing it. You keep on adding new features to it, which means whenever your customer reported this new bug, you don't have the code that you originally shipped your application with. Now, what you have to do in this scenario is either you have to undo all the 20 days of work that you did, like last 20 days of work, and then you have to fix that bug and then deliver him the fixed version of your application. This can be done because we know how to undo changes, we know how to undo commits. So basically what we do is we basically reset all the way back to or reset all the work that we did in the last 20 days so that we'll get to the code base where we were, where we shipped the application. Now we fix it and we ship it. But the problem here is obvious to everyone is I lost all of my 20 days worth of work just to ship my customer's issue or customer reported bug, right? Now, this is where the concept of branching comes into the picture. It's super simple if you understand some of the basics. Imagine right before you started shipping your application, imagine if you can take a copy of your code, which is at the 10th day, right? Let's talk in terms of months. Let's say in the month of January, I worked the code, and at the end of month of January, I shipped my application. Towards the end of February, the customer reported the bug. In order to address it, I have to undo all of my February work, and then I have to fix the bug and then ship a new application to him. Now, imagine a situation where if you can create a copy of the code the way it is at the end of January, so that you start working on a separate copy to improve it further. So just before shipping it to the customer, you take a copy of your code base and then you keep it safe. You don't have to touch it as long as the customer didn't report any issue. You work on the new copy of that code and you start implementing your new features in the month of February. Okay. Now, whenever the customer reports a bug, all you have to do is you don't have to undo your February work. Instead, you go back to the copy that you kept aside, which is only till January, and then you work on it and you fix it, and then you ship the new fixed version of the application to the customer, and the customer will be happy. Similarly, you keep enhancing your application and then your code base. And then what you do is at the end of February, with your new features added, you ship a next version of your, let's call it V2 version of your application. Again, at the end of February, what you can do is you keep a copy of that code base. The copy of that code base will not change as long as the customer has not reported any issue. Okay, so this can be done, but the challenge is, in order for you to keep multiple copies, it becomes slightly tedious. Now, the other case which I haven't talked about is, it's not just that you fix a bug in your January code base and shipping it to customer, but that fix that you did in January code base could also be necessary in your February code base as well. Does it make sense? So whatever bug that he reported in V1 version of your application, that fix that we provided with January code base might also be needed in your February code base, right? Without which, once you release your February code base, the customer will come back with the same bug. You said you already fixed it, but with your recent V2 version, I'm still seeing the same bug, right? So what I'm trying to get to here is, even it's not about you keeping copies of code base, but it is also about being able to intelligently move functionality from one copy of your code base to another copy of your code base. Does it make sense? So without talking more about the theory here, let me introduce you to branches. So Git branches essentially solves this problem. So in order for you to not have multiple copies of the code base, it will take care of all of that mess. So let me just quickly give you the definition of a branch, and then once we do the demo sessions, things will start to make sense. Okay, now to the right you saw basically there are 4 commits here. So C4 will be the most recent commit, my last commit. C1 is my first original commit that I did on this repository. Now, I haven't told you that whatever, when I do git log, all I said was it's basically a list of commits, very similar to your transactions in a statement. But what I didn't tell you is that itself is a branch. You can call that as your January branch, right? Now, so what I'm trying to say here is, branch is basically a collection of commits, a sequence of commits, one preceding other. So C3 is the parent of C4, and C2 is the parent of C3, and C1 is the parent of C2. Okay, so this is called a branch. So implicitly, when we create commits, we are essentially working on a branch. So far, it still looked like a very theoretic example, but bear with me. Once I get into the terminal and once I start running through some commands, things will start to make sense. By default, the default branch name is called either master. It used to be called as master, and these days it has been changed to main. So nowadays, if you see GitHub or any other places, the default branch name is called main. Like I said, I tend to use both master as well as main, but keep in mind that the default branch, even though you don't see it anywhere when you type commands, it's still there. Like I said, the idea of branches is to work features independently. Like the example that I gave you, you can keep independently working on February branch or March branch or January branch. So you can independently work on them. Let's see how it will look like. Ignore this bottom part. Okay. So imagine by the end of January, you did your code, you had like 2 commits, C1 and C2 in your code base. So exactly at the end of January, you shipped your product to customer. And then what we did is, when I create a branch, what Git is essentially doing is it is creating a copy of the code base, this code base, and then you can start working on your January feature. So the bottom one that you see here, B1, B2, B3, B4, are the commits that you created as part of your February work. Okay, so this is basically happening on the code base that you left at the end of the month January. Does it make sense? Now, going back to the same example, as a customer reports a bug, what you can do is you can go back to your January code base and then you can start fixing his bugs. Whatever he reported, the bugs that he reported, you can start fixing on it. And you ship an update to his application here. Okay. Once he is happy, you can come back to your February branch and then you can start improving your application as you wish. Okay, now bear with me. We are going to run through the commands. I'm going to show you exactly what we mean by these branches and all. It makes a lot more sense once we jump into the terminal. Okay, but just keep in your mind that each branch is a collection of or sequence of commits. So when I say this is my master branch, what I mean is my master branch has got C4, C3, C2, C1. So when I say C4, C3, C2, C1, just remember that some work has been done in C3 commit and some other work has been done in C4 commit and things like that. So in your mind, it's not about C1, C2, C3. The naming doesn't make any sense. The thing that you have to, in your back of your mind, you have to remember is some feature has been made in C2 and some bug fix has been made in C3, C4, something like that. You have to think in terms of some code change has been happened in these commits. Okay. Similarly, once I go to the feature branch, basically what I'm doing here is some new features have been added as part of B1, B2, B3, B4. Again, remember, commits are nothing but it's a way for you to track code changes, the changes that you're making to your code base, right? So even though at a high level we talk about commits, behind the scenes you have to think that these commits are nothing but some set of code changes. We don't have to care what purpose those code changes are made for, but all you have to at least remember that whenever we say commits, behind the scenes some code changes have been done to your code base. Okay, now the other important aspect of these branches is especially people who are just starting to understand what branches in Git gets confused quite often is you cannot have two active branches or more than one active branch at any given point in time, right? So this is a very important point that you have to understand, which is you could be either on my master branch or you could be on the feature branch. Again, what do you mean by being on master and being on feature? I'll explain it, but just bear with me. So at any given point in time, a repository, a code base cannot have more than one active branches. I'm using the word active here. I'm not saying a code base cannot have multiple branches. Code base can have multiple branches. In fact, there's no limit to how many branches you can have. I can have January branch, February, or like I can go how many branches I want. But all I'm saying is a code base cannot have two active branches or more than one active branch at any given point in time. The reason for that is it's obvious basically. So let's take an example here. I have in C1 and C2, let's say I have a.java. That's the file I have, right? I made so much of logic or so much of code changes that I have did for a.java, right? Now, where exactly is a.java? A.java is in my hard disk essentially. It's in my C drive or D drive or whatever. It's in my drive somewhere in some location. Now, when I create my February branch, let's call it feature branch, what I did is I added, let's say, b.java. It's another file that I added, right? Now, what does my hard disk has now? I have a.java and b.java, right? Now, when I switch to master again, here, you can switch from one branch to another. So if I switch to master branch, what I will have is I will only have a.java. That's what I mean by active branch. So whichever branch you are on, that branch content will be available on your hard drive. So let's say if I switch to feature branch, immediately what happens is your code base will contain b.java along with a.java, of course. So I just want you to feel comfortable with this idea. When you switch branches, because we don't have multiple branches, multiple active branches at any given point in time, you will only have one active branch. So whenever I switch from one branch to another, the current branch that you are on is called active branch, and the outcome of that is the contents of your project will reflect whichever branch you are on. So if I am on feature branch, I will have a.java and b.java because I created b.java in my feature branch. Okay. If I switch to master branch, which is C1, C2, C3, C4, that b.java will be deleted behind the scenes. You don't even see that. The moment you switch branches, essentially that file gets deleted. So don't get scared when we say the file gets deleted. It's just that Git is putting your repository back to where you were when you switch the branch to master. Okay, we'll go over the examples. Things will start to make sense. So that's what I'm calling out here. The contents of file or folder structure of a repository is determined by the commits on your current active branch. Okay, just keep this in mind. Once we talk about actually doing this, it makes a lot more sense. Now, I'm gonna introduce you to a new command which is called git branch. So git branch, when you type, if you see here, if I type git branch, it will list out all the branches that are available. So if you look at here, assuming if this is your repository, if I do git branch, I would have seen master as one branch and feature as another branch. You can name your branch as you wish. It doesn't have to be called feature. It doesn't have to be called master, but master seems to be the default one. That's why whenever you initialize a repository, you will see the name as master, or sometimes it's called main. But when you're creating new branches, it's up to you to name it the way you want. There is no restrictions to the naming convention. Now, one crucial thing that we have to observe here is when you type git branch, it not only lists the branches but also highlight which is your current active branch. So here, if you see, it's highlighted in green color, and also there is an asterisk before it. So that's what will denote master as your active branch. Okay, so let me jump to the terminal and then let's work out these concepts. Things will start to make sense. I'm going back to the Hello World project that we discussed last time. So if you do git log, hope I increased the font. Hope this is clear to you. If not, let me know. I'll increase it more. What we have here is basically 3 commits. Like I said, log will always read in reverse chronological order. So your topmost commit will be the most recent, and your bottommost commit will be your oldest commit. Okay, so if you look at here, these are the commits, and let's type git branch. Let's see what branches are there in your current repository. I haven't created any branches up until now, but still when I type git branch, it will show me master. That's because whenever you initialize a git repository, git will automatically create this default branch. In fact, that we are working on top of master essentially. Okay, now let me open. I just want to see the contents of this directory with the commands that I'm typing here, so that it makes a lot of sense to you how the contents of this directory is getting changed. Okay, so let me open this code base in VS Code as well, so that we can make some changes on the side. Hope you guys can see it. Okay, now assuming this is my January branch, right? I have been working on this and I have created a application with the Hello World and Hello World 2 and Hello World 3. Those three corresponds to 3 commits that we created essentially. So we want to compile this and then we want to deliver it to the customer. Now, what I wanted to do right now is I want to create a new branch. The way I create a new branch is git branch. Okay, the name of the branch, let's call it feb enhancements, something like that. Okay, you can call it any way you want. Usually the convention that I tend to follow is I try to put the date here just so that I'll remember when I started this branch. So I tend to use 0202. Okay, and then you have to give from which commit you want to create a copy. Remember, when you look at the picture, B does not exist independently. It has to derive from a starting point, right? The idea of creating branches is to make the creation of copies almost seamless, right? So I have to specify a commit, either this one or this one, it's up to me. Okay, so to keep it simple, let's start from here. I copied the most recent commit ID and then I pasted it. I could have done head as well. This will work. I could have also done master as well. Okay. The way head is synonymous to the most recent commit, even the branch name is synonymous to the most recent commit. Just keep that in mind. Okay. Ideally, you are supposed to give the commit ID, but because, as I said, commit ID is hard to read and hard to manipulate, we either tend to use head, or more frequently, instead of even using head, we tend to give the branch name, right? Very almost we don't even give any other commits when creating branch. Usually what we tend to do is we create a branch from the topmost commit. So that's why what we do is we create the branch and we actually give the branch name from basically from which branch you want to create this new February branch. Does it make sense? Okay, now when I do this, a new branch called this will be created. So essentially what I'm doing here is I am at C2 commit and then I created this arrow, and none of this has been created yet. Okay, and also none of these were in place right now. Okay, that's what I'm trying to show here. So now if I type git branch, also look at the content, nothing has changed. We still have hello world.c and no files or no magic has been done here. Okay, now just to see what branches we have, if I do git branch, you do see those two branches, but you still recognize that your master is still the active branch. You created a feature branch called February enhancements, but you haven't switched to it, right? So the next obvious step for me is to switch to that branch so that I'll keep this. Any modifications I make will not affect this master branch. Just bear with me. So the switching command that we use is called checkout. This is where I'm talking about some of these commands gets used in multiple different contexts. So checkout, as you remember, is used to undo changes of modified files, but checkout has this dual role of even switching branches. There are two different use cases. I have no idea why Git designers have come up with these same command for two different scenarios. Ideally, they would have, I think very recently they introduced a new command specifically for this, but people who have been working with Git have been so much used to using checkout even for switching branches. So that's what I'm doing here right now. So Git checkout, when I do this, you see this message, switch to branch XYZ. Now, if I do git branch here, again, git branch will list out the branches. Now, if you see your February branch is made active, that's exactly what you're seeing here. It's which will be highlighted in green and an asterisk. But if you see your contents, no change, because you haven't made any changes here to be precise, right? So your February branch is created and you switched to it, and now what you have is the existing content that you have before, right? Now what I'll be doing is I'll be creating a new file here. Let me go back to code, and then let me create a new file. Let's call it second.java. Doesn't matter what the content is, so let me paste it here. Okay, now again, once you switch to February branch and once I created a new file, also keep an eye on what is happening to your content, right? Because I created a second file, my hard disk, or basically my code base, has got new second.java. Now same previous commands apply here. If I type git status, what it is showing me is there is a file called second.java which is untracked, right? We already know this. Whenever you add a new file, it will be shown as untracked, and you have to explicitly add it to tracking or staging area. From then on, you can keep committing it. So what I'm going to do right now is I'm going to add second.java. Again, these commands have nothing to do with the branching, just that we are on February branch and we are creating a new file. I'm just adding them, and then I'm going to commit them. Again, I don't want to open Notepad every time, so what I'm doing is giving the message right away here. Added a new file to my February branch, something like that, just for me to remember. Yeah. So what I just did is I essentially created commit B1 in my feature branch. Okay. Now the underlying contents of the directory is second.java still there, along with your hello world.c, the first file. Now watch what will happen. Let's also look at the log here, right? If I type git log, the responsibility of git log command is not only show the commits, but more precisely, it will show the commits in your active branch. Okay, so if I type git log, it will show me the commit I created in my February branch. Please ignore these. Don't even look at those things. I'll talk about it later. But what you are looking at here is 4 commits. 3 commits came from your master, essentially, and then the topmost commit is what you created by being in your February branch. Okay, now the most important thing here is what will happen to my code base when I switch back to master. Okay, so what is a command to see the branches? It's basically git branch. Git branch will list out the branches that are there in my code base. Now, if I switch back to the way we switch branches is using checkout. So git checkout master. Watch out what happens. You still have your second.java, and when I type hit enter, it switched to master. So you can see that here. Now your second.java is deleted. Instead of using the word deleted, what Git did is it took your repository to a state where how it was when you created your feature branch. So now you have to just think about the customer scenario that I have talked about in the beginning of the session. So customer reported a bug on your January release and you need to fix it. So all I can do is simply switch to your January branch, like the way I did it here in the master, and then I start fixing it and then deliver an update to his application. Does it make sense? So here I could make whatever changes I want. Let's say I added something like fixed customer bug. Again, like I said, it's not so easy to explain with these Git related features with these trivial examples, but imagine you actually fixed a complex bug or something like that. Okay, so just for the sake of simplicity, I'm just adding new lines to this file. Now I added a line, right? I'm in master. So when I do git status, what it tells me is ignore this file. Oh, excuse me, I accidentally added in second, so ignore that. Let me add it here. Okay, now I should have deleted. Ignore this git status. Okay, when I do git status, what I see is my hello world.c has been modified because I actually addressed customer issue by fixing the bug he reported. So I fixed it, and now what I'm trying to do is basically I'm going to commit it. Fix customer bug some hash 1234 something like that. So every bug will have a bug ID. So that's what I'm writing here. So that people will know, okay, this commit has some fix related to this particular bug. That's how we generally in the company we tend to track by looking at the commit message and the bug ID. So every commit message will have an associated bug ID with it. So I just created a just a second, I shouldn't have given hash here. Oops, I should give minus. So all I'm doing is I'm adding, at the same time also giving the message here. I don't want to open notepad and then control S all that. I'm just trying to give the commit message here. Okay, once I do that, it creates a commit message as well. Now what I did just now is, going back to the presentation, I did this C3. Okay, hope you're still with me. So I created C3 by fixing customer reported bug, and I'm still in my master. Does it make sense? The add command and the commit command are exactly same as what we saw before. It has nothing to do with your which branch you are in. It's just that it works with the current files that are there on the hard drive, current files related to the active branch. Now, just to show you what will happen, right? The current state of the project is my hello world.c, since I am on master branch, has the customer fix. Okay. Now, if I switch to feature branch again, let me list out the branches. And then I'm switching to the February branch. Okay. The moment I switch, look what happens. I got my second.java back. And if you look at my hello world.c, the fix that I made is completely gone. The reason is very simple, because the fix is done in this branch, not here. Does it make sense? So it's very simple if you imagine the contents of your directory or your code base reflects the changes that you have made on your active branch. So as you switch between branches, whichever branch you make as active, those changes will be reflected on your code base, reflected on your hard disk. Okay, just to reiterate, we created second.java in feature branch. That's why when I switch to feature branch, I'm only seeing second.java. And also, since I haven't modified hello world.c in my feature branch, I don't see any modification done to hello world.c in my feature branch. Okay, that's exactly what we are seeing now. If I again switch back to, let's say, master branch, git checkout master. Okay, I just switched it. Again, same definition applies. The contents of the directory or the code base reflects the changes that you have done in your active branch. So here, since I'm on my master, the changes that I did is I haven't created second.java. I have only hello world.c. But what I did is I added a new line into my hello world.c. Now look what happens. Since I switched to master, my second.java has deleted, and then my fix came back. So now if you see, what you're realizing here is my original story, which is it would be nice if you can have copies of two different copies of your code base, right? So Git branch is essentially getting you that ability. So by creating a new branch, you're essentially asking Git to give me a new copy of this entire code base so that I can happily work on it for my February month. And if the customer ever report any bug, I can switch to my January branch and fix the code and then ship an update to his application. Once this update has been shipped, I can happily come back to my February branch and I keep working on my new features. Does it make sense? This is basically the essence of Git branches. Okay. I'll stop here and I want you to let me know if you have any questions related to this specific feature, Git branch. Karthikeya, let me know if there are any questions in the Edgroom forum as well.
No, sir, there is no questions till now.
Okay. So I'm just iterating on what we did up until now. So Git space branch space the name of the new branch. I'm calling it as feature here, but you could call it whatever you want. And then this is very, very important, from where you want to create the branch, right? So this is how it is. When I do Git branch feature head, you can think of it as you're tagging that commit with a new tag called feature. Earlier it has master because master is the default, and also we have head. You can represent C2 with head, you can represent C2 with master, and you can also represent C2 with feature. Right now you can represent it as feature. Now assume you did this Git branch feature instead of head, instead of basically from the top commit. Like I said, you could create a new branch from any commit you want. What I'm doing is, instead of creating it from the head, I'm creating it from my previous commit. It again depends upon the situation. It depends upon how your code is evolving. You don't want your C2 changes, you only want your C1 changes to work with. Then what happens is you try to create a branch out of C1, and then you make changes. It's up to you. This is again how it depends upon how your company or how your project is following the branching model and things like that. Some people, what they do is they they stop at January and they create a branch, and no code changes will be done in your January branch except bug fixes, and your new development will happen in a new branch. Some people, how they do it is They just keep enhancing your master branch as you make new features. Whenever a bug comes, they create a new branch from C1, and then they fix the bug in that branch, and then they ship it. It's up to the way you want to work. Either ways, you end up achieving the effect of being able to maintain multiple copies. Again, we don't use this often, but again, I want to show you there is a way to create branches from any commit that you want. Now, when you do git checkout feature, so what happens is your head, which is on master, will be switched to feature. Again, there is nothing in terms of these pictures. It looks like you're doing there's something happening here, but when you look at the directory contents, no changes are being made here because we haven't done any new commits here. It's just purely to have your mental representation of what is actually happening. So from now on, with each commit on the feature branch, basically the head will progress. So let's say you're on earlier you're on C2, and then you're on master essentially. Now you switch to your branch. This will happen, and then you started working on your February features, right? So your head will progress. So whenever in whichever command, if you put head, it refers to F2. It doesn't refer to C2. Basically, head refers to your current active branch's most recent commit. Okay, so um, now if you just look at it like all of the content that we discussed in first session applies here. I'm just enhancing each of those features with the word active. In first session I told git log will give you the list of commits that you made. Now what saying is git log will give you the commits, list of commits or sequence of commits in your active branch. So this concept of active will play a major role here. So what is your current active branch will reflect the output of all of your commands. Okay, because you switch to feature, when you do git log, it actually shows you the log that is there, that is coming from your feature branch. So you would see F2, F1, C2, C1. Remember, these will still be there because we branched off from the C2. That's exactly what we saw in the log. When we did when we switch to this, and then when we do git log, what we saw is the commit that we did in February, as well as the 3 commits that came from master branch. Just keep that in mind. Okay. Yeah, for everything in git, to confuse people, instead of doing 2 commands, both creating branch and then checking out to that branch can be achieved with 1 command. So the command is git checkout -b feature and master. If you don't want to remember this command, don't remember it. Just basically it's you doing creation of the branch and then switching to that branch. Okay. I just want to take a minute to see. Should I continue, or do you want to? Do you need a break? Okay. So let me continue. Let me switch back to master. As I switch to master, my second.java is deleted, and then I have my bug fix. Now, what happens is, very often when you're fixing bugs, eventually you have to backport those fixes to your current branch as well, right? Because if I do not have this line in my February branch, the customer will again come back and report that the fix that you gave me is no more working with your February v2 release. Okay, so the so to answer that, what we essentially need is merging. So what let me explain what merging is, right? um, let's look at the picture. I have C1 C2, and then this is basically end of January, right? So I created a branch called feature, and then I started working on that particular February feature, which is F1 and F2. Now the customer reported bugs, so I switched back to my C2, and then I switched back to my master, and then I started fixing those bugs, C3 and C4, like that. Now what I want is, somehow I want to bring those fixes into my feature branch. Okay, does it make sense? Because otherwise, if I release my feature branch to the end of February, the customer will report again, the fix that you gave me with your January update no more works with your February release, right? Which means, even though we tend to do fixes by maintaining independent copies of your code base, there comes a time where you have to merge them. We have to get those changes into your feature branch as well. Does it make sense? Also, the other way is also true. You probably, as part of an experimentation, let's say this is your main branch where you try to ship your products every time. As part of your experimentation, you created a separate branch and you started working on some experiments, some code changes. And then you felt confident that this new feature is shaping out well, and this is your prime time to ship it. Now what you can do is, instead of creating a product out of this, you can merge all your changes back to your master. Does it make sense? So the second dot java that I created, I want that second dot java to be part of my master as well. Okay, so let me show you what happens when I do that command. So here what I'm trying to do is, I want to bring whatever changes I did, F1 F2, into my master branch. So keep in mind, uh, which branch, wherever you see head, that will be your that will be your active branch. In this left side, the head is on top of master, which means your this thing, these C1 C2 C3 C4 is your active commits, active branch basically. Okay, now when I do git merge feature, because I'm already on master, what I'm saying to git is, merge all the changes that are done in feature into myself. That's exactly what this command mean. We don't say where to merge because we are already on the master, right? So all you say is, merge all the changes that are happened in your feature branch back to master. That way I'll have second.java as well, along with the bug fix. Okay, so this is very frequently used a feature of git when you're working on real world projects. So just to give you another example, in Windows what we have is, we have a branch called master, right? So every time we release new operating systems like Windows 10, Windows 11, or Windows Next, whatever it is, we tend to release it from the master branch, right? But we also tend to fix bugs as part of released versions. So let's say Windows 10 is released like almost like close to 10 years now. Now people will be reporting bunch of bugs in it, right? So what we do is, we fix those bugs by creating individual bug fix branches. Even though I'm calling it as feature here, we usually call it as bug fix branches. So we create a bug fix branch, and then we fix the bug, and we validate it. And then what we do is, we want that fix to be also available in the next version of Windows. If not, the customer will come back and say the bug that you fixed for Windows 10 is no more working in Windows 11, and Windows 11 already, Windows 7 has the same bug again. So what we generally do is we merge that bug fix branches into the master again. So this is generally the way in which all projects work. So the point that we have to remember here is, I'll walk you through the demo. It makes a lot more sense there, but keep in mind, all you're trying to get here is the changes that you are done, that you made in your feature branch, will be merged into your current active branch. In this case, master being my active branch. All these changes, in this case, we created a file called second.java, and probably I could have modified the second.java in F2, and then all of those changes essentially will be merged into the master branch. Okay. I'll talk about this later. Let me just go over the changes and then we'll see. Let me clear the screen. We have two branches and I'm on master. And since I'm on my master, the contents will be just hello world.c with the bug fix. And if I switch to February branch, in February branch, I have no bug fix, but I have a new feature that I'm developing. Let me call this as second.java. Okay, let's not do that now. So I have second.java and I have some other changes, right? Now go back to master. Okay. Again, the contents came back to hello world.c. This is deleted. So with the bug fix. Okay. Now look what happens when I do merge. Git merge. Since I am on master, I don't have to specify master again. All I have to specify is git merge and then the branch from which you want to pull the changes. Even before I do this, I'm just commenting out that command. You can use two semicolons to actually two colons to commit a to comment a command in command prompt. So when I do git log, in my master branch, all I have is bug fix and my existing three commits. Now let's see what happens if I merge. If I do git merge, so don't care what this is, but all you care is look at the log. When you look at the log, what you see is you get let me show you this way. So this will basically abbreviate the commits so that it's easy for us to look at. So what we are seeing right now is, ideally, since we are on master, we are supposed to have only these three commits and this bug fix. But because I merged with feature, what I have right now is I also got the commit that I created in my feature branch. Okay, so ignore this log, but just look at the contents once. I am in master, but what happened is I got second.java. Not only that, I still have my bug fix. Does it make sense? So I have my second.java, which came from my feature branch, and also I have my bug fix. Okay. This is what I meant by merging. So once this code base is merged, I can effectively delete this feature branch, this February branch. Deleting February branch is not harmful because I already have all the changes from feature branch. You can leave it, but generally to keep your Git branch output clean, once you're done working with your bug fixes, you tend to delete them so that the output will be much more readable. Does it make sense? So it all boils down to the way your requirement is, how you want to work with. So I'll stop here. One other detail I want to call out here is When you create a merge commit, when you merge two branches, it also creates a dummy commit called merge commit. This commit will not have anything. So if I try to do git diff tool, I'm trying to see what is there in this top commit, right? All we need to have is, ideally all we need to have is only these commits. But when I look at git log, it appears there is this unknown commit which I neither created in when I was in my master, nor I created it when I was in my February branch. So that empty commit will be created by git just to indicate that this commit is responsible for merging of these two branches. So if I undo that merge commit, again the commits, again the branches will be split apart. Let's not go there, but let's try to see what are the contents of this. Okay, the head will be here on the topmost commit. I'm just trying to see what the contents of that merge commit. All it is saying is, even though you kind of added this second.java, but technically it's an empty commit. It will not contain any content. Git generally shows you the contents of all the content that you brought from that feature branch. Okay, so just keep in mind, when you do merge operation, you not only bring the changes from whatever branch you're merging from, but also it creates this empty commit. And the mental picture within git internally represents it in this form. So you could effectively, the hard drive or the project will contain both the files. Let's keep it there. There are fancy command line options that you can provide, which will basically visualize that in the command prompt. I'm not going to go there because it's very rarely used thing. But when I do just git log, it will show me in a sequential fashion. But if you do these extensive command line options, it actually shows you like this is the master and this is your feature. So it is basically showing you the actual graph that we see here. Okay, again, let's not go there. We don't need that functionality. All we care is, did I get the changes that I made in feature or not? That's all I care. Hope this is clear to you. Okay. Now, in order to get the changes that are done in feature branch, what we saw up until now is this feature called merging, right? We can do this merge command and then merge the changes. Now, that's not the only way to get the changes from your feature branch. There is slightly another way to get those changes, right? So we call that feature rebase. Rebase is the term that is used in Git to again get a similar functionality. Let's look at that. Let me know if you want me to stop before I go to rebase. Let me give you a minute. Again, these things seem complicated, but the problem with Git is partly the terminology itself is slightly convoluted, in the sense that same word gets used for multiple scenarios, and also it's very hard to even explain these features by a tutorial or by some of these with some tiny examples. You have to actually work with some really decent sized projects. Then you will start appreciating how valuable all of these merge and all of these advanced features are. generally for your lab programs, it hardly make any difference. But I believe once you get to do your final year projects or anything like that, which involves at least 5 or 10 files, these things make a lot of sense. So another example is you probably would be doing projects in a team of, let's say, 2 or 3 people, right? Like more than one person, right? So what can happen is your teammate would be creating a new branch and he would be working on his specific functionality. And then at the end of, let's say, a milestone, let's say end of like 15 days or 1 month, what you can do is you can get his changes back to your branch. So you can create P1 for to denote person 1, and then P2 branch for person 2, P3 branch for person 3. And once they are ready, you can basically merge them one after the other. So at the end of the month, you will have your collective work. You don't have to manually copy his changes into your files and then or the other way around. So let me jump into rebase as well, because I tend to use rebase more than merge, but there is a place for both of them. Merge gets used in some scenarios and rebase is used in some other scenarios. Okay, so let me just walk you through what rebase is. Even before I give any definition, let's look at the picture, right? This is what we have, right? Even when I'm discussing merge, this is what we have. We have a master branch with bug fixes here, and we have our feature branch with our feature development. Now, generally, the F1 is called base commit of feature branch, because that's the commit where your new feature started developing, right? So the word rebase mean you essentially change the base, which is pointing to C2 to C4, like this. So what I did is I moved these two commits, and then I dragged it all the way under C4. So C2 is no more your base commit. Instead, C4 is the base commit. I actually wanted to highlight this. So when you do rebase, essentially what you're doing is you will be on your master, and then you will be rebasing it. You will be basically dragging these F1 and F2 on top of C4. I'll show you how we do that, but all we have right now is effectively we got all the changes. Since again, remember, head is on feature, which means our feature is the active branch here, unlike the merge example. Now what I'm trying to do here is I'm pulling my bug fixes that are done in my master into my feature branch. Does it make sense? I could have created git merge master here, which would have created a merge commit and then pulled all the changes that happened in my master to my feature. That's one option that can be done with merge command. But the other option is I could have just rebased my F1 F2 below C4, right? Imagine you just created a new branch under C4. What will happen? It will have your bug fix changes as well, isn't it? So that's exactly what we mean by rebasing. Rebasing means basically realigning your base commit so that it will get all the changes that are happened in C3 and C4, which we in our case it's bug fixes. Okay, does it make sense? Let me show you this so that you will understand what I mean. Before I can show that, I need to undo some of these changes. So bear with me. Let me do CLS. Okay. So I have my two branches. Again, I'm just going back to my master branch and my feature branch. Let me switch to my feature branch. What I'm trying to do here is I want to pull the changes from master to feature branch. Let's try the merge way first. So I have second.java since I'm on my feature branch, and I have hello world.c, but it doesn't have the bug fix. So let's try the merge approach. Because I'm on my feature, so the command will be git merge. I want to pull the changes that are there in master to feature. So I'll just indicate master because I'm already on my feature branch. So let me show you that. So I'm already on my feature branch. So Git has this very good feature. When you misspell something, it tries to autocorrect what the command I meant. So even though I misspelled branch, it knows that I'm trying to type branch. That's why it gave me the output. Anyway, so this is the active branch. So what I'm trying to do here is git merge master. Now, what it will do is it will add a merge commit and not only get the bug fix commit from master, but also creates a merge empty commit. Don't worry too much about that merge commit, but all you have to care is you'll get that bug fix line here. Okay, so if I do that, you got that. Okay, but pictorially, what is happening here is this. There is a line here like this, and there is a commit m indicating merge commit. Again, the position of m is very, very important. The m gets created on feature branch because feature is our active branch. Earlier in the previous slide, the m got created on the master branch because because master is our active branch here. Okay, wherever is the head, that branch will be the active branch. Here, what we did is the other way around, just to make the point very clear to you. So I'm on feature branch and I merged from master, all the contents from master. So basically you have to imagine that you have an arrow here and then there's a m commit created here pointing to this. Again, this is again pictorial representation, but end of the day, all you care is what are the contents of my hello world.c file, which happens to have the fix from master, which is all I care, which is what all I care. This is with the merge way of doing it. Okay, let's also try to do it with rebase way of doing it. Okay, before I show you the rebase, let's look at the log of feature. Because I'm on feature, when I type git log, I'll only get the log from git feature branch log. Okay, let me do the simplified version of it so that it's easy to git log one line. So what you're seeing here is your first 3 commits from master, and then the second commit from feature, and then bug fix from master, and then followed by a merge commit. Okay. Looking at this log, it is very clear it's so much hard for you to even understand which commits came from which branch, and it becomes so complicated very quickly. So since I am making these changes, I'm able to recollect that this commit has been created in feature branch, and whereas this commit is created in master branch. But in real world, it becomes very, very, very hard for you to look at the log. So just keep in mind, merging branches, even though achieves the effect of what we want, it does have some effect on the log. Git log output doesn't look so nice. It doesn't look sequentially. One commit you see coming from feature branch and one commit coming from master branch, and then on top of that you will see a merge commit and things like that. It's kind of messed up. There are reasons why it is messed up, but it's not very easy for a developer to understand what it is actually showing. Now, just keep that in mind. Let me show you the rebase way of getting your changes from master to this thing. So first, let me keep a copy of this somewhere so that we can refer it later. So just for the sake of it, I'm putting it here. And now I have to undo these changes. So bear with me. Don't even look at here. Yeah. So basically what I have now is I undid those changes. So again, I am in my feature branch the way I was. Like I have second.java and then hello world.c doesn't have my bug fix. Okay. Now, so we are here. Master has the bug fix, feature has the second.java. Look what happens when I do the rebase. The way we do rebase is again very similar, just that instead of merge, we do rebase. Git rebase, and then I'll give master. So what I'm saying it is rebase my base commit with whatever is the topmost commit of master. So effectively, what it is doing is, in a way, deleting the feature branch altogether and then creating a new branch out of your C4, which is basically the latest commit of master, and then redoing those two commits that you did in your feature branch. That's what it means by rebasing. Just look at the picture. So delete this whole thing, create a new branch, and then reapply those two commits. Right? When I do this effectively, now I get my bug fixes as well into my feature branch. Okay. When you're reading log, you have to traverse this whole thing. When you do gitlog not just show f1 f2, instead it shows c4 c3 c2 c1, all the commits. Okay, let's look at that. So before I run this, just for one more time, I do git log. Git log is showing me 3 commits from master and the last commit which I created for the second.java. So let me rebase it. So all it says is successfully rebased, and you have no idea what is happening behind the scenes. But all we care here is the contents first. Did I got the bug fix from master or not? Yes, I did get the bug fix that I did in master. But now just look at the log. Let me do that one line logging, so it's much easier to look at. Do you see this now? It's so much nicer because you know those 4 commits that came from master, and then it applied your feature branch commits. So there are no intermixed commits, and also interestingly, you don't see any merge commit here. Does it make sense? So I'm just comparing with this and this one and this one. Look at this output, git log output, and this git log output. This has intermingled commits from feature branch and then master branch and then finally the ugly merge commit. So then obviously the question comes is like, if the log is so ugly, why do we need to even have merge commit, right? The reason why we still prefer merge is because, in fact, I showed you without explicitly explaining it. At any given point in time, I can undo my merge. So that's exactly what I did to show you or compare you between merge and rebase. By having this dummy commit, once I reset that commit, each branch are on their own. So I get that benefit of being able to not only merge them, but also undo the merge. Essentially, keep the branches as separate. Don't even merge them. Okay. You lose that ability with Git rebase. Does it make sense? So both merge and rebase has their own pros and cons. The rebase we use very often to keep the log clean. Merge we use when we want to make sure we have an option to undo any changes. Okay, and I'll also explain not just this scenario, but where exactly rebase is more preferred versus where exactly merge is more preferred. Okay, once we get into GitHub and stuff like that. But for now, so there are 2 ways. The bottom line is there are 2 ways to get your changes from other branch into your current active branch. One is merging, the other is rebasing. Merges the content. content, and then but it creates this merge commit. Now rebase on the other side, what it does, it also gets the changes, but instead of creating the merge commit, it kind of reapplies your changes on top of your latest whatever it is, master or whatever it is. Does it make sense? So just I want to show this slide again. So we are here, and then we did rebase, like the word itself should reflect what we are trying to do. Rebase, read it that way, right? So you're basically rebasing your commit, I mean the base commit, onto whatever is the latest. Here C4 is the latest on master, and then I am rebasing onto it. Okay. Any questions?
No questions.
Okay. So are you guys able to follow what I'm talking here? Can someone respond? I
Yes.
assume silence is yes. So okay.
Yes.
Okay. So one hope you guys understood this. I'm not keeping track of time, but 8:30. I think we're almost on time. Okay, let me take a couple more minutes, which is very much needed actually. So I haven't answered this question of to keep things simple. What I did is I created a new file. So when you're merging things, there are chances when you get something called as merge conflicts. So imagine the scenario. In master, I modified this line, right? Let me go back and do the example that is much more easier for you to follow. I'm not sure whether I'll be able to do it now because I kind of I did the rebase. That this is the disadvantage of using rebase. I cannot go back. Because I did merge, I was able to undo that commit, and then I was able to redo it. So now I am unable to do it. Let me quickly get back to the state where we were. Get reset. Again, I have aliases for commands as well. That's why I'm typing CO. CO stands for checkout. You need to configure that. So just bear with me. So git branch, I am on master. Okay, let me check out to. This is another disadvantage of using rebase. So it's very hard for you to do undo changes. So I'm on my this thing and I don't have this file. Let me create second.java and then let me copy that. Okay, and then okay. Let me see the log of. And by the way, you can whenever you are on master, you can also see the log from log of feature branch. You just have to give the name of the branch. I'm not deliberately. I'm not complicating things, but okay. I think we are at a state where we were. Okay, so what I'm trying to show you here is, let me switch back to master. You're already on master. Oh, sorry. Check out master. Okay, since I'm on my master, yeah. Since I'm on my master, I have my bug fix and I have my original changes, and I don't have second.java. Okay. Now, what I'm trying to show here is uh, in my master, I modified this line, right? Now, let me go back to my feature branch and modify exactly the same file and also somewhere similar, somewhere around exactly at that line. So what I'm doing is check out. mm, so I have my second file. So what I'm trying now is in my feature branch, I'm trying to add a line here exactly on the same line and calling it as um, added in feature branch, something like that. Okay. So let me commit it. When I do git status, I'll have this, and then I can do added a new line to set hello world.c. Okay, so basically what I did is I created a new commit with this hello world.c file modified in my second branch. Now, the scenario that I'm trying to explain here is a file has been modified in both the branches, both in my main master branch as well as in my February branch. Now, when you ask Git to merge them, right, it gets confused. Like it has no idea what line should it prefer, right? So let's look at it. I'll clear the screen and then if you look at the branch, I'm on my feature branch. Now I'm trying to merge from master. Okay. I hope you're following with me, and what you're seeing here is I look at the left side picture. I'm on my feature. I'm trying to merge with master. So what happens is you get an arrow and you create a merge commit here, right? So I'm going here and then git merge master. Immediately, what you see here is it tried to merge. It applies a lot of strategies to merge the conflicts, but eventually it will give up. Conflict merge conflict in hello world.c. Okay, and this is a failure essentially. It's not a success. Unfortunately, it didn't feel like a failure because it doesn't show in any red color or anything like that. But if you look at the status, it says both modified. Both modified as in this is how it will show the file. Okay. So because this line has been modified in multiple places, Git has no idea how to put them together when you're merging stuff. Purposefully, I showed you in a different file with second.java, not to get any conflicts, just to explain you what merge is and what rebase is. But when you're making modifications to the same file in two different branches, eventually when you try to merge, you'll end up with this thing called merge conflicts. So I try to merge and I end up with merge conflicts, and it says both modified hello world.c. Both here I mean both your current branch as well as the master that you're trying to merge from. So what it does is it gave up, and then it gives up, but what it does is it puts these markers into the file hello world.c. Let me explain these markers. What it is showing is this is basically two parts, second part and this is first part. There are two parts to this conflict. We call this entire thing as conflict, and the conflict has two parts. This part, which it is denoting as head current branch, means this line has been added in your feature branch. And then what it is saying is this line, whichever you are seeing below this equal to signs, is actually coming from your master. Now tell me which line to include. So Git gave you this, and then Git basically gave up and no idea what to do. Now, as a developer who made changes into these two branches, you have much better idea of what line to keep and what line to remove, right? Because probably in your feature branch, you not only have the bug fix, but also you kind of added something more to it, right? So you are in a better position to decide whenever merge conflicts happen, to indicate Git that don't worry, you just take this and ignore about this. So merge conflicts are something that you as a developer have to resolve. Git cannot handle those conflicts on its own. So what I did here is I kind of, in this case, what I did is I picked the bug fix and also appended my own modifications. Again, I'm explaining here with just printf statement, but imagine it's a bunch of code that you have to figure out and then merge them accordingly. Okay, so what I am doing is I picked the changes from feature master branch, as well as I included some more changes from my feature branch as well. Okay, now you save this file. Always you have to remove these markers. If you have less thans and greater thans like this, Git will not proceed further. So you have to, what you have to do is you have to make sure you resolve that conflict by removing those conflict markers and appropriately make the changes. And then what you have to do is um, you basically add the file again. Okay, and then you say merge hyphen continue. So merge commit is responsible for creating merge command is responsible for creating merge commit. So basically it opened a text editor, just showing that here is the conflict that we just saw, and you don't even have, the message also will be automatically written by it, so you don't even have to do anything. You just have to save the file and then quit it. Okay, now if you look at the log, so basically you resolved it and then you created a merge, this thing. Basically you merged both the changes. The same thing can also happen when you're doing rebase. Rebase can also end up with this situation. Okay, even there, let me also show you that quickly. Git, I'm just undoing this merge commit so that I'm again in my feature branch. Let me show you the contents with my hello world added in feature branch line. Now what I'm trying to do is I'm trying to rebase. I'm just trying to demo you. Even rebase will end up with this same situation. Okay, so I'm going to do rebase. This commits will be pulled and applied on top of C4. Unfortunately, both in C4 as well as in F2, we modified hello world.c. So same file got modified in both the branches. So we should end up with similar merge conflict. Let's see that. Git rebase master. Because I'm on feature, I just have to denote what branch I want to merge. This time the error message seems little different, but again, the point is very similar. It tried to merge it, but it gave up. Luckily here it is actually calling out more clearly, indicating that something happened here. Okay, but if you go back to the code, what you're seeing here is again the same marker, same story. So hello world.c, again it says this line came from the head, and then this line was added in your whatever is the rebase branch. Okay, so again, idea is you have to remove these markers, and then maybe as a developer, you know much better than what Git is assuming. So what I'm doing here is essentially taking the bug fix from that line, and then again I'm saving the file. Now once that is saved, I do the same thing. I add the file, and then I do rebase hyphen continue. Okay, it just asks me like, do you need to make any changes? I don't need to make any changes to the commit message. And if I do git log, this time again, since it is a rebase, it doesn't have any merge commit. But the thing is, like, it will have a very nice and clean log message. Okay, So I think this pretty much covers what I wanted to say in this session. All we try to cover here is we did see this. So I'm just indicating the same thing. When you do rebase, what will happen? So that's why I'm calling this as F1 prime, not F1, because sometimes you end up with the completely a new commit. It's not your old commit. Okay. Another important thing I might need to call out here is when you're merging, the commit IDs will not change. Commit IDs still remain F1, F2. The contents will be brought and merged into merge commit. But when you do rebase, what happens is the commits will be replayed, which means it unpacks it almost like you deleting this whole thing and then you creating a new branch and then reapplying, basically recreating new commits on top of this new thing. That's why you see the commit IDs will change when you do rebase and they don't change in case of merge. Again, a little bit of details there. You don't need to worry about that. But effectively, the most important thing is like the conflicts have to be manually resolved. Git cannot auto resolve some of these conflicts. It does a good job in resolving some trivial conflicts, but sometimes it cannot. So here is the recap. We did see how to list branches, and how we can create a new branch. You specify a new branch, and then you specify from which branch you want to create. Okay, this is very important. So many tutorials don't talk about this, and because you don't explicitly specify that, it end up assuming something else, and a new branch gets created from some other commit, and you will end up with a lot of mess. So always try to create a new branch from an existing branch. Most of the times this will be master or main or branch name. Very rarely you have to give the commit ID, but that is how it works. Now you do git checkout the new branch name to switch to it. Again, remember, when we are switching branches, what we are doing is you're changing the underlying contents of your code base in your hard drive. When I switch to feature, I have second.c. When I switch to masters, second.c is deleted. That's the whole point of switching. Essentially, branching concept is created to have us maintain multiple copies of the code base, at the same time provide us the ability to merge them whenever we need it. Okay, so you do check out to switch branches, and then, like I said, this is a more fancy command to create a branch and also switch it. Experienced people tend to use this more often. So whenever you see someone using this is effectively you creating a branch with this and then you doing this. And then we saw how we perform merge with whatever branch. Again, the important point here is, what is your current branch? What is your active branch? That's very, very important, because that decides where the merge commit to be created. So if I am on feature branch, if I am on master branch, and if I do git merge feature, my changes from feature gets merged into master. So it's like asking, give me all your changes to me as in my active branch. Okay. Similarly, when I do rebase all the changes with the feature. So I'm on master, and then so let's say I'm on feature and I want to rebase with master. So all I have to do is git rebase master. I want to rebase my current branch with master, so that gets reapplied uh, uh, with the latest commits from master. Things might sound complicated. Thing that you have to do is just follow these diagrams. It makes things a lot more simple. So that's all I have for today. Let's take a couple of minutes and then we'll stop it here. Again, the reason why we split this into three parts is I want to make sure you really get the value of how to use Git. And like I mentioned in the previous session, it's very, 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 very complicated for you to learn Git alone, as well as from people working in the industry. I have seen like 90% of the people in the industry do not even know how Git is supposed to be used, but they tend to use it happily every day, and they get their job done. But without these fundamental building blocks, without understanding them, whenever something like a merge conflict happens in a bigger scenario, it becomes so hard, and they have no idea what is happening. So take your time to go through these slides, and feel free to ping me, not just during the session, even offline, so that I'll be able to clarify the questions and explain things much better. So the next session will be just an addition on top of this. Again, it's not that complicated. Just it uses this foundation, but yeah, I'll try to keep it as simple as possible. Karthikeya, are there any questions on the Edgroom forum?
No, sir.
Okay. So thanks, guys. If you have any questions, feel free to let me know. I hope at least the 1.5 hour that you spent today is worth. Yeah. Thank you, guys. I'll stop the presentation now.